Okay, so this is a copy of the notes that we took yesterday on lesson 23. I'll just go over a few of the points. Number one, the answer was that you can use the quadratic formula for all second power trinomials. So by second power, I mean x squared, and by trinomial, I mean 3 terms. Number two, what is the discriminant? In the quadratic formula, the discriminant is the part in red under here, the b squared minus 4ac. That comes in really important in today's lesson. Everybody in here can hear me? Cool. The square root of a negative number is imaginary. So you just need to know that for now. We're not going to deal with imaginary numbers just yet. Just be aware that that's the term that we use to refer to something like, that's an eraser. If you get something like this, like negative 33, that is technically imaginary. And you don't need to worry anything else about it for right now. The other thing you need to go into today's lesson is you need to know that the standard form of a quadratic is ax squared plus bx plus c equals 0. So that means that you need to get all of your equations into standard form first. That was a skill that we practiced yesterday and on last night's homework. I'll go over one of the homework problems to make sure that we all get the right answer. And I'm going to pick question number, what do you guys say? What question should I do? 14? Cool. 14 it is. All right, so question number 14, left-hand side, is 9x squared equals 23 minus 9x. So I'll take that from here. I'll put it onto my loose leaf. Okay. Now that's not in standard form yet. Remember that standard form is ax squared plus bx plus c equals 0. So we need to make sure that all of our terms are on the same side and that it's equal to 0. So the first thing we'll do is minus 23 minus 23. I get 9x squared minus 23 is equal to negative 9x. Last thing I have to do is move over the 9x, so plus 9x plus 9x. And my final trinomial is 9x squared plus 9x minus 23 equals 0. Now that's super important because from there is where we get a, b, and c. So this is a, this is b, and this is c. A equals 9, b equals 9, and c equals negative 23. When I go to the quadratic formula, I'm going to plug these in, and I'm going to plug them in with parentheses around them. So my quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And for whoever who's subbing, if this is too fast for you, you can always slow down playback in the bottom right corner on YouTube. So what I'm going to do when I plug them in is x equals negative b, which is 9, plus or minus the square root of b squared, which is 9 squared, minus 4 times a times c. I'm just taking these numbers and this guy, plugging it in there, taking this and plugging it in there. That's all I'm doing. Divided by 2a, which is 2 times 9. Now we're going to simplify a couple things in the calculator. Simplify this, and simplify this. Once I do, I'm going to get x equals negative 9 plus or minus the square root of, what's the number? 81? Cosine that, Hellerka? 81? Okay. So underneath here, if you plug this into your calculator exactly the way it's written, you're going to get 81. On the bottom, you get 18. If you paid attention in the part of the class where we were simplifying radicals, you'd be aware that 81 is a perfect square. So this is equal to 9 squared. This square root here is like a bouncer at a club, and he's asking for an invitation. He wants 2s. The 9 has an invitation, so he's allowed through. So when I rewrite this, it's going to be x equals negative 9 plus or minus 9. There's nothing left under the square root, so we don't have to write it. On the bottom is 18. To get a full credit answer, this right here would be 3 out of 4 points. 3 out of 4 points isn't good enough. What we're going to do is we're going to divide all these terms by 9 because they have a GCF. Divide the bottom and the top, all terms, and what you're going to get is negative 1 plus or minus 1 over 2. So if you wanted to break this up, remember that plus and minus is 2 separate answers. So you have 2 answers. You have negative 1 plus 1 over 2, and you have negative 1 minus 1 over 2. Both of those can be simplified. Negative 1 plus 1 is 0, so 0 over 2, and negative 2 over 2. Those can both be simplified one more step. This is just going to be 0, and this is going to be negative 1. What you got? So if you miss the simplification step, that's fine. Just be aware of it in the future. Now let's move on to the back of the sheet. If you don't have notes out by now, you really should, because what we're talking about today is the discriminant. The first question on the back of our sheet says, what does the discriminant tell us? So we're going to answer the question number 18 first. What does the discriminant tell us? Now, who can remember what the discriminant is? The discriminant is b squared minus 4ac. It's the part that's underneath the square root in the quadratic formula. So the good thing about the discriminant is you don't need to memorize it. It's on your reference sheet. If you zoom in here on the quadratic formula, you zoom in, you'll see the discriminant is right here under the radical. B squared minus 4ac. So the thing that you really need to remember about it is, what does it tell us? Well, if the discriminant is there are 3 options. If it is positive, what it means is it means that you have 2 real roots. That means essentially that the graph of your function crosses in 2 places. That's what 2 real roots looks like. I'm going slow so that everybody has a chance to copy it down. If I move on and people are still copying, you can just pause. Another option is it could be negative. Now, I'm going to explain this verbally. If the discriminant is negative, you get the square root of a negative number, right? Because the discriminant is under the square root in the formula. So we just learned yesterday, we wrote it in our notes, that the square root of a negative number is imaginary. So what we get out of this is we get 2 imaginary roots. Now, what does an imaginary root look like on a graph? Well, just like you can't see imaginary friends, you can't see imaginary roots either. So your graph of your function may look something like this, where you notice it doesn't actually touch the x-axis at all. It has no roots. The last option is that we could have the discriminant equal to 0. if the discriminant is equal to 0, we don't have two separate roots. Remember that the discriminant is plus or minus the square root of the discriminant, right? So in this case, that would be plus or minus the square root of 0. The square root of 0 is 0, so plus or minus 0 is the same thing. If you have $5 and I take away $0 from you, you still have 5. If you have $5 and I add $0, I give you $0, you still have 5. They're the same thing. So plus or minus 0 is actually the same root. So sorry, there's a little more writing in the box for 0. But these are the same root. So there's one real root. And what that looks like is this. One root. And it's like a turning point where the graph of the function just touches the x-axis in one place and then it turns around. You're going to want these in your notes to refer to. I'm just giving you guys a second to finish the notes because I got to scroll down a little bit to make some room to do a question. So. Okay, so let me give you an example for number 19. Number 19, this whole section just says use the discriminant. Are the roots below 2 real, 2 imaginary, or 1 real? So those are the options you're going to be writing for this section. This doesn't really take a lot of work. If you're particularly good at this, you might not need to use loose leaf, but I always prefer to have the extra room. So if I'm talking about 11p squared plus 7p plus 9 is equal to 0, the good thing about this is that it's already in standard form. I don't need to go moving terms around. If you noticed that already, then good for you. So number 11. I have to identify A, B, and C. A is going to be 11, B is going to be 7, and C is going to be 9. I'm still going to write all of these explicitly because identifying them for some people is a skill all on its own. 11 is A, B is 7, and C is 9. Now all I'm doing is using the discriminant. So what is the discriminant? The discriminant is b squared minus 4ac. I feel like Dora the Explorer, asking questions and then answering them myself. All we're going to do is plug in. So b squared, remember b is 7, so I've got 7 squared minus 4 times a, which is 11, times c, which is 9. You can plug this into your calculator exactly as is. As long as you use parentheses, you will get the correct answer. But I'm going to do it piece by piece because I like doing math on paper and math in my head more than I like using the calculator. So I've got 49 here minus 44 times 9. I changed my mind. I don't want to multiply 44 times 9 in my head. Virginia, what's the answer? For this part? Mm-hmm. For the whole thing? For the whole thing? Negative 337? 347. Sorry, the headphones make it kind of hard to hear. Minus 347. So that's what b squared minus 4ac is equal to. So this is negative, right? So what kind of roots do I have? I've got a negative discriminant, but what's up with my roots? They're imaginary. So I've got 2 imaginary roots. Nice and simple, right? So you just evaluate this and match it up with the table. Okay? So I want you guys to do some practice problems now. I want you guys to finish 20 through 24, and I'll give you 5 minutes. Go. So, substitute teacher, if you're listening, just pause it. Count out 5 minutes. Okay, I'm just going to go over them quick. You guys didn't have to. For here, b squared minus 4ac, this is a, b, c. I'll just do a couple of them so that anybody who did the practice knows they did them right. So b squared is 12 squared minus 4 times a, which is 6, times c, which is negative 90. It's important you get your signs right. So I'm going to use an on-screen calculator. I know the 12 squared is 144, so I won't even bother plugging that in. So 144 minus 4 times 6 times negative 90. And I get 2,304. 2,304. So this is positive, and that means that I have 2 real roots. Now, if you want to see more examples of this because you need help on your homework tonight, just check out my YouTube channel. I'll have a video uploaded on this. For now, let's move on to the next section. All we're going to be doing is putting together the skill that we learned today and the skill that we learned yesterday. A lot of the time, it's very helpful before you go doing the quadratic formula to use the discriminant first, because it's really quick, to test what you think the nature of the roots are going to be. Is this quadratic formula or this quadratic equation going to have real roots? Is it going to have 1 root? Is it going to have imaginary roots? It's always easy to test in the first place before you go finding them with the quadratic formula. If you have to graph, for instance, you might not care if it turns out the roots are imaginary, because why bother with the quadratic formula? You can't see those points on the graph anyway. So I'm just going to go through number 25 as an example. You could always back up and replay it if the kids need more examples, okay? So after number 25, I'll assign homework questions. Number 25 says 12v squared plus 3v plus 11 equals 0. It's already in standard form. I figured you had enough work yesterday with moving things around that I would just go and give you the standard form version, save you a little bit of effort. A is 12, B is 3, C is 11, and they're all positive. Now I'm going to predict first what the roots are going to be by plugging into b squared minus 4ac, the discriminant. When I plug in, I'm going to get 3 squared minus 4 times 12 times 11. I'm going to do that all in my calculator. Once again, I know that 3 squared is 9, so I'm just going to write that as 9. So 9 minus 4 times 12 times 11 is going to be equal to negative 519. Negative 519. So what we have, if you refer back to your table, is we have 2 imaginary roots. Imaginary means the square root of a negative number. So this is what we're going to get when we solve for the actual roots with the quadratic formula. So let's take these same numbers, a, b, and c, 12, 3, and 11, and we're going to plug them into the quadratic formula. We'll solve and we'll simplify if possible. So remember, 12, 3, and 11 are a, b, and c. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. As I plug in, I'm going to get that x is equal to negative 3 plus or minus the square root of 3 squared minus 4 times 12 times 11 all over 2a, which is 12. If you've been paying attention, we already solved what this is underneath the radical. We already have that number. So when you do it this way and you test first and then you plug in, it's like you've already done part of the work of the quadratic formula. So I know that underneath the square root, I have negative 519. So I've got x equals negative 3 plus or minus the square root of negative 519 all over 24. Whenever you have a number under a radical, or under square root, you should still be checking for perfect square factors. Negative 519 may not be, you can take that one, yeah. Negative 519 may not be as simplified as it can be. So I'm going to go to my list of square roots and see if any of them divide in. If they don't, it wouldn't be surprised because 519 is kind of a weird number. But we still want to simplify. So I'm going to bring up my calculator again, and I'm going to try dividing some perfect squares into it. So remember that the perfect squares are like 4, 9, 16, 25, etc. So I'm just going to test some of them until I'm confident that there is no factors, or maybe there are. 519 divided by 9. Nope. 519 divided by 16. Well, that's even, so I know it's not going to work out. 519 divided by 25. 519 divided by 36. 519 divided by 49. 519 divided by 64. All the even ones are not going to work, but you can test them and find that out yourself the hard way if you want. 519 divided by 81. 519 divided by 100. And the last one I'll check is 121. I'm pretty convinced at this point that there are no perfect square factors, which is something you should always be before you box an answer. You should be sure that it's as simple as it can get. The only thing that I can do to simplify this, not going to simplify that guy, but I can simplify this. What I can do is I can split this into two fractions with a plus or minus in the middle. So my first fraction, x equals negative 3 over 24, plus or minus. Now the same denominator, but the other term in the numerator. So the square root of negative 5, I keep writing the 1 first, negative 519 over 24. And I can just simplify this. This can become, divide them both by 3. I'm going to get negative 1 over 8. Plus or minus, the right side can't be simplified. And this right here makes it imaginary. So mathematically, these are the roots, even though they're imaginary, so you won't see them on the graph. Okay, now your homework is going to be 29 through 33. Hopefully you have some time to start on that in class, but that is due Monday. Good luck.